Tell me, you two, have you seen this notation before? If I said vector r equals xi plus yj plus zk, and you know it, and you can write it like this: x, y, z, and basically it just represents a vector. And guys, from this morning, which axis is this usually? Yeah. J, K, yes. Okay. Right, so that's our vector r, and we had three formulas. So the first one was the magnitude of r, and then the theta and the phi. So the theta is if there was a shadow on the ground. What's this angle here? The phi is the angle between the vector and the k, and the magnitude is the length of the r vector. So our formulas were familiar. Y squared. Yeah, that's the tan inverse y over x, and this one was cos inverse z over root x squared, y squared, z squared. So that's what we were looking at this morning then. Okay, so if I could just borrow that book there. So I think we're just kind of continuing with that. Yeah, we're just continuing with this. It's not so difficult. So we'll look at a couple of these together. So we'll look at the first one. Can I scroll down? Yeah. So here's two vectors. Vector A, I said, is 13, 86, and 2. And vector B is 31, 68, and minus 2. So I want you to check if the following is true or false. The magnitude of A plus the magnitude of B equals the magnitude of A plus B. Okay, if you can take out your calculator, see if this is true or false to begin with. You can do this too, I think, yeah? Got your calculators? Not convincing.
True.
No.
False.
Yes.
This is what I have to put up with, you see.
We have to expand the whole thing.
No, you can just, this will be square root, these three squared added together, and you can leave it as just a decimal on each side. So, have you got the left? Yeah. So what I'll do is, I'll do an easy one and then I'll do a hard one. So we'll start with this one. Okay. Is this true or false? What did we get?
True. False. Let me try. You're not so fast.
Do you have anyone like this in the science group, you know? Like just, no, like this. Yeah, okay.
Are you not wrong?
Okay. But not as bad, right?
Maybe.
Oh, maybe, okay.
False.
It's false. It's false, yeah. If you calculate this, it's false. In fact, it's always false. The rule, this isn't the rule. The magnitude of A plus the magnitude of B is not equal to the magnitude of A plus B. It's not equal here. The second one here, B, magnitude of A plus the magnitude of A equals the magnitude of 2A. So that is, if you get the length of A and add it to itself, is it the same as doubling the vector and then getting the length? So this would be the magnitude of 26, 172, is it? And 4. Is that the same as this magnitude plus itself? So in other words, 2 root 13 squared plus 86 squared plus 2 squared. So what do we think here? Is this true or is this false?
False. True. True.
Okay. It doesn't work if you give me both answers, Lee.
True.
It's true. It's true, yeah. Okay, C is the same. Is the magnitude of 2A equal to 2 times the magnitude of A? And just like the last one, that's true as well. D, the magnitude of A to B is equal to the magnitude of B minus the magnitude of A. Now, this is a rule that you probably, maybe you've actually seen if you've done vectors before, but there's a rule here to give you the vector AB, B minus A, yeah. So the question is, if I calculate this AB, will I get the same answer as the length of B minus the length of A? Well, what do we think? Let's have a look at AB. So that's B minus A, so that's 31 minus 13. What's that, 18, is it? Yeah. And 7, 12, 18 again, is it? And minus 4? Minus 4, isn't it? Minus 2, minus 2, yeah. Is that the same thing as the length of B? What am I doing? Length of B minus the length of A. So if you hit that in on the calculator, will you get the same thing? Well, I'm kind of feeling like the answer will be false. Because I can see that this is a positive, this is a positive, this is a positive, but it's possible that this side is a negative, and this side could never be a negative. So, yeah, it is false here. And then the last one, E, is the length of AB equal to the length of B minus A? What do we think here? True or false? It's true, yeah. Yeah? Scroll down? Yeah? Okay, so let's see why this is useful. Imagine I give you this point here, I'll call it A, and we'll say that this vector is 2, 1, 2, and then we'll call this one here B, and we'll say it's 7, 1, 1. And I want to know what is the distance between A and B. So I want to know what is this length here. And of course this is the usual origin here. So I want to know what L is. Alright, so what's the idea here? How could we find the length between A and B?
B minus A.
But what is B minus A?
OB minus OA.
Yeah, but why? What's
Because A to O or to B.
Huh?
Yeah, but I'm looking for length. So the length from A to B is not the same length as A to O and then O to B.
Oh.
What is the length actually?
Triangle.
Maybe we could use some kind of rule.
Triangle.
You're thinking to find the angle?
Triangle.
Not necessarily right angle. We could do that. No? No? Any ideas? Yeah. Yeah, but why subtraction? Like what?
The triangle rule, because we have 3 lengths. We have 2 lengths.
Yeah, no, I understand what you're getting at. You feel like we can know the length for A,
Yeah.
and we can know the length for B. But the problem is, we don't know this angle. I mean, if we knew this angle, we would be finished, because we could use the cosine rule. This length squared equals this squared, which we know, plus this squared, which we know, minus twice this, cos this. But we don't know this angle between A and B.
Y.
We have what?
Y.
Oh yeah, don't worry about that. In this example, maybe it's the same, you're right, but just in general.
We can find a 90 degree.
No, nobody knows. So the length L is the magnitude of the vector AB. Why is that? You did not say that.
AB
You did not say that.
Wait, I said that.
Yeah, B minus A.
But why?
Because the magnitude.
You never said magnitude, and you never said why. Alright, what else? Why? Okay, because the length from A to B is simply the length of a vector drawn from A to B.
No, it's
What should we call this?
What?
I don't know. The positive stuff.
This?
Magnitude.
Magnitude.
Oh, okay.
Yeah. Now we can say what AB is. B minus A.
But why?
We proved that last time. So this is the...
That's what I say. It will all to be.
No, but you understand how English works, don't you?
You have to understand him.
Okay.
No, you have to understand you have to understand how English works. B minus A, that would be magnitude of 5, 0, and minus 1.
Yes.
So that's square root of 26.
Gross 26.
Yeah.
Yes.
Yeah, so that's the length from A to B, is root 26. So this is one reason why magnitude is a useful thing, because it can actually give us the length between points. Okay, so as another example, if you can write that down, please. And then we'll have a look now as another example, number 6 here. Okay, 6.
Wait.
What does 6 come from?
I'll write it down here. Yes. Just before we go on to 6, imagine I have two vectors, one here and one here, and the only difference between them is their, well, not the only difference, what I should say is the relationship is that they're parallel, okay? So this vector here, it doesn't matter, we'll just say it's x, y, z. If I know they're parallel, I actually know something about this vector if I know the one that's parallel to.
Lambda and
It's a factor of this, yeah, so some number like lambda could be taken out in front. So that's one useful thing which we should remember when we look at number 6 here. So in number 6, I give you a vector A, which I tell you is I plus 2j, and a vector B, which is 3I plus 4j. And my first question is, C is lambda A plus mu times B. And I just want you to simplify this. So all you can really do here is say this is lambda 2 lambda plus 3 mu 4 mu, which I can just add together to make lambda 3 mu, yeah, 2 lambda plus 4 mu. So that's the simplest I can make vector C. Okay. B. What's the magnitude of C? Okay, well the magnitude of C will be square root.
Lambda.
Yep, lambda plus 3 mu squared plus 2 lambda plus 4 mu squared. Right, let's calculate this.
let's calculate this.
Yeah. Lambda squared plus 6 lambda mu, yeah, 9 mu squared, yeah. 4 lambda squared plus 16 lambda mu, yeah. Good. Now we'll clean this up a little bit. Is there much I can add together? I have lambda squared, and I have 24, 22, 22 lambda mu plus 25 mu squared. Yeah? Okay, so that's part B. That's the length, the magnitude of vector C, depending on what the mu and the lambda are. Okay, part C now. what is the relationship between lambda and mu if C is a unit vector? Now, does anybody know what I mean by unit vector? What exactly is 1?
The magnitude.
The magnitude is 1. So unit vector just means the magnitude of C is 1. So if I tell you C is a unit vector, it means you know then that 5 lambda squared plus 22 lambda mu plus 25 mu squared has to equal 1. Because that's the magnitude, and I just said the magnitude is 1.
Square root?
Yeah, but square root 1 is still 1, so we can actually drop the square root.
No, I mean, do we need to the square root?
Well, if I put the square root in,
Yeah.
I would then just square both sides.
Oh.
So it actually doesn't matter then. I can just leave it like this. Is that okay?
Yeah.
D. What is the relationship between lambda and mu if C is parallel to AB? And AB is B minus A, which in this case is, what's B minus A? 4 minus 2 and 3 minus 1. So I tell you that C is parallel to AB and AB is 2, 2. Because we have the AB from the start. AB will be 2, 2. So what is the relationship, or what is the formula I can make if I tell you C is parallel to AB?
Lambda 2,
Yeah, go on. Lambda plus 3 mu. No, you're right the first time. Because if I tell you C is parallel to this, it means C can be written as some constant times 2, 2. Which is just 2 times a constant and 2 times a constant. They're both 2 alpha, 2 alpha. In other words, beta, beta. In other words, if C is parallel to 2, 2, it's just a way of saying that the 2 components must be the same. So it means that this component must be the same as that. So you can say that lambda plus 3 mu, is that right? Lambda plus 3 mu is 2 lambda plus 4 mu. Or another way is just saying lambda plus mu equals 0. Is how you can simplify this. Now you can kind of get a feeling for what's going on now. I mean, what's going to happen next. So you won't be surprised if I tell you the next thing is to find lambda and mu. And it's not as bad as it looks, because this can very nicely just say lambda is minus mu. So I can actually put that back in here. 5 mu squared minus 22 mu squared plus 25 mu squared equals 1. So what's that? 30 minus 22 is 8, isn't it? 8 mu squared is 1. So mu is 1 over root 8. Yeah? Which is 1 over 2 root 2. Which is, if I multiply above and below by root 2, I get root 2 and I get 4 here. But of course lambda is minus mu. So then I just get lambda is minus, is it not? The top and bottom multiplied by root 2. Minus root 2 over 4 then. So if you think about what you've done now, what I started off with was saying vector C is some multiple of A plus some multiple of B. Let me try and draw what we've just done. Can I just put it here? Can you see? What did I say vector A was? You can just remind me.
1,
1, 2, was it? So if I draw that 1, 2, 3, 4, 1, 2, 3, 4. So 1, 2 would be like here. This is vector A. And what's vector B?
3, 1.
3, 4. So that's vector B there. And the first thing I did was I said C is so many A's plus so many B's. So I took some A's and I took some B's and I added them together. So we know how to add that together. That's using the parallelogram law. So that there is vector C, where it's so many A's. No, it was lambda, wasn't it first? And so many B's. I add them together to make C. But I also told you that C is a unit vector, so actually I probably drew it too big. If it's a unit vector, it should only have a length of 1, so the C, I'll shrink the picture down to, something like, whatever, something like here would be the C shrunken down. What else do I tell you? I also tell you that it's parallel to AB. So there's vector AB. So because it's parallel to AB, when I shrink it down to 1 unit, it kind of looks more like this. It's parallel to AB, and it has a unit length. So what I've not done yet is I've actually not worked out what the C is, but from looking at the picture, it should be kind of a small number, something like 2, 1, or something like that. So I think what I'll do to finish it is you could put these numbers back in to see what the C is. So on the top it's lambda plus 3 mu, and that's lambda minus 3 lambda minus 2 lambda, isn't it? So minus, so actually it's underneath, isn't it? Minus 2 lambda, so that's minus, where's lambda? So root 2 over 2. And then this one is 2 lambda plus 4 mu. Of course it's the same, yeah. Root 2 over 2. So, yeah, like we thought, it's a small vector down here. You're looking a bit confused. I put these two values for lambda and mu back into this, just to get the C. I know for a fact that these should be the same, because I actually said earlier in part D, C is parallel to AB, so I know from the beginning that I should get two answers the same here. So actually, once I calculate this, I also know this. Yeah. This would be like an exam question in that it has multiple parts. Now, it's a tiny bit easier than what you would get in the exam, because in the exam, they'll also ask you things like this, which we haven't done yet. They might ask you a question like, what is the angle between vector A and B? They could ask you something like that. Or they could ask you to draw a line between AB and find some other vector that points to somewhere on this line. These are the other things we'll have to do in this chapter then. But for this chapter, this lesson, we're mostly just working on magnitude and direction then. Okay, so if you can try these for a few minutes then, and sure, if you want to go, you can. You can share with KJ. What's wrong?
Dad,
Huh?
you guys are going to do that later.
Yep. We finish on the normal distribution.
I'm going to do trigonometry.
Yeah, they used to have trigonometry in the science syllabus, but they cut it out. I don't know, I think it was a bad idea, because I think you needed...
So much more.
Yeah.
Oh, it's so boring.
What is it you're doing? Confidence intervals.
Yep.
Yeah.
What was the chapter before this?
Normal distribution.
No distribution.
The same worksheet?
Yeah.
It's about...
No, you didn't use the book.
Oh, we're not using book, we're using worksheet.
John did a...
We still have a book.
But does it look like that?
Yeah.
I don't know, it's terrible. Did you get your coursework yet? Or not yet?
No.
Because you haven't done the chi-squared yet.
Yeah.
You know this one?
The next one.
It's the next one, is it? Yeah. Are you guys doing any of the medicine tests, like for Charles or Masrick or whoever? No?
Not really.
Not you two, because you're science then, so you're not needing to do any of these tests. See, I kind of feel bad for the students that have to do these tests, because they ask them things like complex numbers, complex numbers with the I, trigonometry,
But it
and
hasn't-
vectors.
But they haven't gone through it.
Well, yeah, so this is why I feel bad for them, because they're asking them maths questions which they don't cover. But the stupid thing is, it used to be on the science syllabus, but then they cut it out.
Why?
Because they thought it was too big, the syllabus.
It's not.